Welcome to the session on syntax of KLogic. Whenever we talk about the syntax of a particular logic, it becomes necessary for us to understand the formation rules. Let us look into the formation rules for model propositions. Whenever I have an atomic model proposition, that by itself is a model proposition because the formation rules will be recursively increasing. So an atomic model proposition is a model proposition. Then any model proposition P by prefixing it with the unary connectives like negation, box, and diamond are all model propositions. And if I say that we have a P and Q to be model propositions, then P junction, conjunction Q, P disjunction Q, P conditional Q, and P biconditional Q are all model propositions. Then each of the model proposition that is generated by applying one or more of these three rules iteratively, it will generate a model proposition. So here we are talking about the syntactic representation of the model proposition. So if we look at the Backus normal form of the grammar for model proposition, and more specifically the KLogic, then we have the truth value, the false value, any atomic model proposition. And if we consider X as a valid model proposition, then negation X, box X, diamond X, and yes, conjunction with X, disjunction with the X, conditional and biconditional are all valid model propositions. Let us look at the well-formedness of the model propositions. So we have a couple of examples given here, and we also know the grammar of the model logic, specifically the KLogic, and let us see whether the formula that are represented here are syntactically valid or not. Okay, so when I say I have a formula which is well formed, when we apply these grammars that are given for the logic, I should be able to get this to be satisfying. Okay, if we look at the first one, okay, so whenever I have a box, it is a unary. Yeah, I have a unary model proposition here, and here for conditional, I have proper parenthesized, and anyway, the outermost parenthesis, when the meaning does not change, we can avoid. So all those general rules which we discussed as part of propositional logic is applicable here also. And accordingly, if we look at the first one, yeah, it is a valid or a well-formed model proposition. Now let us look at the second one and see if it is a valid model proposition or not. So the rules that are given here, on applying all of them, are we able to get it? No, because see, in this case, we have a conditional and the open parenthesis for enclosing that is missing. Okay, so that way this particular model proposition given is not well formed. Now let us look at the next one. If you individually look at it, yeah, for this it has been parenthesized, and this has been parenthesized, and I don't have the unary connective to be connecting in a binary manner. So this is also a well-formed formula. And when I look at the next one, yes, this has only one model proposition to be present for this also, and this has been parenthesized. This, all of them are parenthesized. So this is also valid. Now let us go to the next one. So if I look at this, parenthesizing has been happened appropriately, but I I have this and a connective followed, a unary connective followed by a binary connective, and I'm not having any proposition associated with this unary connective, hence this is not valid. Okay, so whenever the syntactic correctness are to be checked, we need to be looking at whether the entire formula is based on recursively applying this or not. So how we can do? Probably we can replace it with another symbol and keep checking whether the pair are existing or not. Now let us look at how we could be checking otherwise as to whether the given formula is well formed or not. As we have discussed in case of propositional logic, here also we can use the parse tree. So any model proposition, I should have only a unique parse tree that should be existing. And if X is a model proposition and we say that X is equal to exactly one among those which are represented here, that is, it could be true or false or an atomic proposition or a negation of Y or a box of Y or diamond of Y or a conjunction with the Y and Z, a disjunction with Y and Z, or a conditional with Y and Z and a biconditional with Y and Z, where exactly Y and Z are also model propositions. Okay, so any model proposition that is following the rules and represented would have a unique parse tree. So if we consider the given example, so here, so the first, how to say, connective that has to be applied is this unary connective diamond, so that starts at the root. And the outermost parenthesis, if we eliminate, we see that the conjunction is the one that connects, so conjunction would be coming as the next one. And on the left hand side, if you look at the left hand part, the box is the one. And then if you remove the parenthesis, you know that biconditional is there. And on the left hand side, we have a P. On the right hand side, we have a negation P. Similarly, if we move on to the right hand side of the conjunction, then first we have the outermost one is the box, and then you have a parenthesis. If we remove the parenthesis, we are going to be having, so this parenthesis, if we remove, we have the disjunction to be present, so disjunction. And on the left hand side of the disjunction, we have box, where again within the parenthesis you have an implication and you have a Q and P, and on the right hand side of the disjunction we have a negation Q, and this is how a parse tree is generated. And anyway, this is the manner in which we have done that as part of propositional logic also, and this parse tree is going to be unique for this.